In today's lesson, we're going to be solving quadratics by factoring. How do you tell when to stop after factoring or continue solving? Let's look at the examples given. The stop after factoring example reads 2x squared minus 9x minus 9. The continued solving by example is 2x squared minus 9x minus 9, but it's equal to 0. So the big difference, and I'll highlight it, is that equal sign. When you put an equal sign into your quadratic expression, that is now an equation you need to solve. Let's try solving already factored out equations for the x values in the examples below. The first example here, again, how I solve each one is set each parentheses equal to 0. 3x plus 4 equals 0. And then I also have x minus 2 equals 0. All I did was take the two factors in the parentheses and set each one equal to 0. I go ahead and add 2 on this right side equation to get x all by itself, x equals 2. And then on the left side equation, I have to subtract over 4 to move it to the other side away from x. And then I have to divide by 3 on each side. X will be equal to negative 4 thirds and 2. You might see your multiple choice answer in a what we call solution set, which is these kind of squiggle brackets with your two numbers inside. The x value of negative 4 thirds and the x value that can also be 2. And you close the squiggle brackets, that's called a solution set. You might see the format for it. Let's go ahead and try example 2. Again, I split up my parentheses and set each one equal to 0. 2x minus 8 equals 0 and 5x minus 5 equals 0. Solve each one. I'll go ahead and do the left one first this time. It truly doesn't matter, but I'll add 8 to each side to get x by itself. Last thing I have to do, it's 2 times x, so I must do division to get it away. X equals 4 is a possible x value for this quadratic. Then I add over 5 on each side for this right side equation to get 5x is equal to 5, and it's 5 times x, so do the opposite, which is division, to get x equals 1. Again, write it in your solution set. That will be 1 comma 4 in those squiggle brackets. Let's recall that the standard form of a quadratic equation is y equals ax squared plus bx plus c. And the definition of a quadratic equation is it's an equation containing one or more terms with the highest exponent of any variable being 2. That's exactly what we have in example 3. It's in standard form. As a reminder, that's ax squared plus bx plus c. And if it's not in standard form, that's going to have to be what you do first. You must have it in standard form, and you must have one side equal to 0. So this whole function is equal to 0 now. I'll change out the function notation to 0. So that's already done for our first step. Let's check it off. Second step is we factor out by division the greatest common factor if possible. Well, there's no single number that I can divide from 1, 5, and negative 14, so that's already done because my A, B, and C values are 1, B is 5, and C is negative 14. If they were all divisible by the same number, I would do so, but not in this case. Next step is drawing our big X. So I'll kind of keep doing each step as we go. Place A times C up top of your big X is step number 5, which would be negative 14. And remember, B stands for bottom. Now we got to find two numbers that multiply to the top and add to the bottom. So never forget that it's multiplying to the top. That's why we do factors of the top that will add to 5. So let's list out some factors of negative 14. That would be 14 and negative 1, and negative 14 and positive 1. That would be 7, negative 2, and negative 7, comma 2. The only ones when I add them up that get me 5 are 7 and negative 2. So that's what I've split my middle big X term into. So let's take the previous quadratic we had. X squared plus 5x minus 14x equals 0. I split up that middle term with the big X to be 7x and negative 2x. Those were the two coefficients I chose for my big middle X term here. Bring down the first term x squared, and it's a positive 7x. Keep these signs with the coefficients. And then we bring down the last term, negative 14. Still equals 0, so that way I know to solve when I'm done factoring, but we need to do the last step of factoring, which is number 7. Use the box method or grouping method to get your answer into parentheses. So I'm going to use the box method here and place all 4 terms into my box. X squared, then 7x, then a negative 2x, and then negative 14. X times x is going to get my first term plus when I divide out my row here. The only term or number I can take away from both is x. And then same thing when I'm looking at my column. The only thing I can divide out from x squared and negative 2x is an x. Then once I have my column number 1 and my row number 1 headers, I'm going to go ahead and kind of work backwards here. So I'm going to think about this x value needing to multiply with 7 to get to 7x. Whatever number would multiply to get you the result inside. And same thing, I'm going to think backwards for the outside of my last row header. That is going to be, I already have x. I need negative 2 as my row header to multiply with that x to get negative 2x. My parentheses, now that I have them, are going to be x plus 7 and x minus 2. I set that equal to 0, and then each parentheses gets equal to 0. That is step number 8, which I will then solve for. To get x by itself on the left side equation, it's going to be subtracting 7 away because opposite of addition is subtraction, leaving me with x minus 7 on the left. And on the right, I must add 2 to each side, giving me x equals 2. Your final solution set, what you write as your final answer, is going to be negative 7, comma 2 in those squiggle parentheses. Let's try 2 more. I notice I have 2 terms on the left side and 1 term on the right side. That's all my 3 terms here for my trinomial. Remember, trinomial means 3 terms. But I need it to be in standard form, and I need it to equal 0. So the only way to do that is drawing my line and changing the sign on to move it over to the left side. That way here, let me get rid of my numbered terms. 2 minus 2 comes out to be 0, which is what I want on one side. Other side can't combine negative 2 with either 5x squared or negative 3x, which is good. I just need to combine and write it in standard form. So I take the x squared term that comes first in standard form, my ax squared. Then my bx comes next, so my x term, negative 3x. And then my c is my solo number with no variable, negative 2. That is now in standard form and equal to 0. Over here in this next example, number 5, again, I have 1 term over here on the left and 2 on the right. So I'm going to move the left term over because it's moving 1 term instead of 2. Now, this really only works if you can get your A terms, so I'll highlight my A term in number 4 and in number 5 to be positive. I really want that term to be positive when factoring. It's just going to help save a lot of time. When you add over 4n to each side, you get 0n over here on the left side. So you know one side's equal to 0. And all I got to do on the right now is write it in standard form. 4n squared comes first because your x squared term is a. And then your b term is on the variable n, just no exponent on it. And then your c in our factoring of trinomials will be 1. It's just your number with no variable. Let's go ahead now that we actually have these equal to 0. Let's go ahead and solve. So all I'm going to do is copy down what I just solved for because that was step number 1. Step number 2 is to see if I can divide anything out from all of them, which I cannot. 5, 3, and 2 are not divisible by anything of the same. I'm going through my steps again. So my next step is to identify A, B, and C. A equals 5, B equals -3, and C equals -2. After I have my A, B, and C, always remember the big X comes next because in your big X, you can now place A times C up top and B on the bottom. A times C is -10 and B is -3. You're thinking of factors that multiply to the top number always and add to the bottom. So factors of -10 will be -5 and 2, and 5 and -2, 10 and -1, and -10 and +1. The only ones that add up to -3 are -5 and 2. So that's exactly what I split my middle term up into. My big X has two separate sides now. It's going to be -5x and +2x. You bring down the last term, you did nothing with the number. You also did nothing with your first term number of 5x squared. All we did was separate our big X term. Now we go ahead and do the box method I will do here to solve and get our two parentheses for factoring out this equation. 5x squared goes in the first box, then -5x, then 2x, that's positive, and then -2. So to help me get the first row and column headers, I'm looking at the row here, 5x squared and -5x, and seeing what they're both divisible by. They both have an x and they both have a 5. Let's try the column. 5x squared and 2x, the only thing divisible from both is going to be x. Then we have, again working backwards, a 5x already being multiplied with a number I don't know to get -5x. Well, that number now is -1. And then again, let's think about this bottom row. I already have an x up top. What's going to multiply with that x to get the 2x inside? That must be 2, my row header below. Check your work if the last two numbers here, so I have -1 and 2, if they do indeed multiply to -2, your last and final box, you know you did this correctly. You go ahead and have each equation or each parenthesis specifically being set equal to 0. We'll write it out in its true factored form, and then we'll split it up to solve each one. 5x squared plus 2 equals 0, and x minus 1 equals 0. When I add 1 to each side, I know that x is equal to 1 as my first solution. Second solution in this case, I'm subtracting 2 and then dividing by 5. That's going to give me x equals -2/5. As a solution set again, we can write it back here at the top, put squiggle brackets with -2/5 and 1. Let's try the example number 5 again, using what we just solved for in example 5 above. I can only factor, it's so important, when I have my standard form on one side and equal to 0 on the other side. A, B, and C is where I start. That would be 4 for A, 4 for B, and 1 for C. We go ahead and draw our big X where we put A times C up top, which will be 4 in this case, and B for the bottom, which will be 4. Factors of the top that add to the bottom, let's go ahead and look at them. Factors of 4, we have 4 and 1, -4, -1, 2 and 2, -2 and -2. The only ones that add to 4 are 2 and 2. So that's exactly what I split up my middle term into here. So I will keep 0 equals 4n squared. But instead of this 4n, I'm going to split it into the two factors I chose here, 2n and 2n. And I will add 1 at the end, bring down that last term. This is when I go to my box, and then I can solve from there. First term is 4n squared, second term is 2n, third term is 2n, and then the last term is 1. Again, I look at my first row and divide out what they have in common. That's going to be 2 and an n variable. Let's look at my first column. Divide out what they have in common. 4n squared and 2n are both divisible by 2n. Then we have to see what we will get, how we get 2n when we multiply it to n. Well, that will just be a plus 1 because we already have the 2n. We just need a 1 there to be multiplied with it. Look at your bottom row. Again, the top column already reads 2n. To get to the 2n in the box, we just multiply by 1. Check your work. If the 1 times 1 does get you that fourth box, you know you did it correctly. We write it out as 2n plus 1 in the first parentheses. That's the column headers. And then the row headers, 2n plus 1 in another parentheses, will be equal to 0. I set each of parentheses equal to 0, but notice that they're the same parentheses. So no matter what, if 2n plus 1 equals 0, the same result will be when I set my other 2n plus 1 equal to 0. So I'm going to go ahead and subtract 1. 2n equals -1. I'm going to divide by 2 on each side. So my only value for n is going to be -1 here. That's my only value since both parentheses were the same. When both parentheses are the same, just a side note here, you might see this as 2n plus 1 squared equaling 0. That would be the equivalent